Hey guys, so today we're going to look at some applications of laws of sines and cosines, and you have to determine based on the problem which law to use in order to help you solve the problem. So a couple of steps. The first thing we're going to do for any word problem is to draw the picture if it's not already done, and then we're going to find a triangle in the figure and label it ABC. Set up your 6 variables to see whether you have a match set or not. And if we have a match set, we know that we can use law of sines, which is a little bit easier than law of cosines. But if we don't have a match set, then we have to use the law of cosines. And so let's go over an example of each as a review. So in the first problem, we have, because of prevailing winds, a tree grew so that it was leaning 4 degrees from the vertical. So instead of standing straight 90 degrees from the ground, it's leaning 4 degrees over, which means that from the ground to the tree, it's 94 degrees. At a point 40 meters from the tree, the angle of elevation to the top of the tree is 30 degrees. We want to find the height of the tree. So let's start by redrawing this triangle, just a sketch. And I'm going to relabel it. So this is 94 degrees. This is 30 degrees. I know that this is 40 meters. And I'm looking for the height of this tree. So I'm just going to label my triangle ABC. And the height of the tree that I'm looking for, that's going to be my little c, the side opposite angle C. And so that's the information that's given. That's what I'm looking for. And if I look at the diagram, it doesn't look like I have a match set. However, because I know 2 angles in this triangle, and I know that the sum of the interior angles of a triangle add up to 180, I can do 180 minus 94 minus 30 degrees to figure out the measure of angle B, which comes out to be 56 degrees. And now we have a match set. And so now I can set up my law of sines equation using my match set. 40 over matches with 56 degrees, so 40 over the sine of 56 degrees equals, and then the side I'm looking for would be C over the sine of angle C, which is the sine of 30 degrees. Okay, and then make sure that when you're doing this on your calculator is in degree mode, and then we're going to cross multiply. So C times the sine of 56 equals 40 times the sine of 30. C times the sine of 56 equals 40 times the sine of 30 degrees. And then to solve for C, we're going to divide both sides by the sine of 56. Make sure you close your parentheses. And you can go ahead and type that into your calculator. 40 times the sine of 30 degrees divided by the sine of 56 degrees. And you should have the length of side C as roughly, rounding to the nearest hundred, 24.12 meters. And that is the height of our tree. So because we have a match set here, we can use the law of sines. Let's look at one more example. We've got surveying. So to approximate the length of a marsh, a surveyor walks 250 meters from point A to point B. So he's walking straight. And then at point B, he has to turn 75 degrees. And then he walks 220 meters to point C. And we have to approximate AC in this diagram. So the triangle is already labeled, so I'm just going to go ahead and continue labeling this. ABC is labeled. I'm looking for the length of AC, which is really little b, the side opposite angle B. And angle B we don't have. What I'm given is that exterior angle, which is 75 degrees, but I know that if I add 75 degrees plus whatever this angle B is, it should give me 180 degrees because they are supplementary. It makes a straight angle, right? So we can do 180 minus 75, which will give me the measure of this angle right here as 105 degrees. And that's all the information that we have. So looking at the information, I can't figure out any of the other two angles because I only know one, and so I don't have a match set. Okay, so in this case, we're gonna have to use law of cosines. So law of cosines. And remember, law of cosines, we always start with either the side that we're looking for or a side that is opposite the angle that we're looking for. So since we're looking for little b, the equation that I'm going to use is b squared is equal to a squared plus c squared, the other two sides, minus 2 times a times c times the cosine of angle b. Okay, and so that's the formula, and I'm going to go ahead and substitute it in. So I have b squared is equal to little a, which is 220 degrees, 220 meters squared, plus 250 meters squared, minus 2 times 220 times 250 times the cosine of angle B, which is 105 degrees. And then again, make sure that when you're calculating, your calculator is in degree mode. And so to solve for B, B is already almost isolated. I just have to get rid of that squared. So to get rid of that square, we're just going to take the square root of both sides. And so B is equal to, in your calculator, the square root of all of that. The square root of 220 squared plus 250 squared minus 2 times 220 times 250 times the cosine of 105. So if you type that into your calculator, careful of your parentheses, make sure all your parentheses and exponents are in its right place. And it comes out that B is roughly 373.32 meters if we round to the nearest hundred. And that is the length of AC that I'm looking for using law of sines. So go ahead and try the practice problems for 4.6, and depending on the problem, draw out the triangle, label what you're looking for, and label the triangle with ABC, and then determine whether you're going to use law of sines or law of cosines. So use your calculator and show all your work. If you do not have a graphing calculator, you can go on to Google and type in scientific calculator, and one should pop up where there is a where there is a sine, cosine, tangent, log, all of that option for you to use.